In this video, we're going to start to look at the machining options within Carveco Maker and all of the toolpath operations that are available within the software. There are various ways to access the toolpaths. One way is to select the toolpath drop-down and you get all of the options under there. There's also some icons here which contain some of the toolpath operations, and then you also have toolpaths under the project tree. So if you select that, it opens all of the toolpaths underneath the splitter bar. My personal preference is to do this because I can then see all of the operations. Now, what I'm going to do first of all is under 2D toolpaths, you've got Create Profile Toolpath. So I'm going to create a profile toolpath. A profile toolpath is just basically a cutout, okay? And what I want to cut out is this square. So if I select the square, and you take a look down the very bottom right hand side, you can see that it gives me the width and the height of this. So this is 6 inches by 6 inches. So if we open up the Create Profile Toolpath, and it opens up this quite long dialog box. Now I'm going to show you how to do this really basic at first. So just cut the part out using no additional options. So first thing to do is decide how you want to machine this. So do you want to machine this on the outside, inside, or along the vector? Now, if you want to cut the part out and you want it to be 6 inches by 6 inches, then you would use the outside. So what this does, it moves the tool to the outside of the vector and then cuts around it. If you were to select inside, it would move the tool to the inside of this vector and then machine it. So if you were taking this part out and you wanted to use it, it would give you a smaller piece by whatever the diameter of the tool times 2 is. If you select along, then this will machine along this line. So that's the center line. So this will be smaller by the diameter of the tool. Don't worry if you don't get it. I'm going to show you in a moment what the different options do. Right, so for the time being, let's use outside. And I'm not going to worry about any of these options. All that I need to do is enter a finished depth for this. So if I come down to the bottom, I need to first of all set up my thickness of material. So I already actually have something set up here. Most of the time when you come into this, you won't have any material set up. So if I click the drop down and then select setup, and it gives me a material setup. So this is just basically setting up my Z height for the material. So let's say I wanted it to be 1/4 of an inch. So you enter in material thickness 1/4 of an inch. The material Z0, now this is all dependent upon your CNC machine. So if you set up your machine to be at the top of the material, then you click that little circle at the top there to denote that it's on the top. If you set it up to your wasteboard, then set it to be at the bottom. And the program will automatically work it out for you when it comes to cutting. So I'll just set this up to be at the top. Model position in material. Because we're not doing any 3D work, don't worry about this. So this is only important when you're doing any 3D machining, okay? And it just basically means where the model is within that material, because it could be smaller than what the material actually is. So don't worry about that, especially not for the time being. So just select OK, and that material then is set up. So I can see my Z bottom is -0.25 inches. Okay, so let's come back up to the top. So finish depth, I want to cut this through the material. So let's go 1/4 of an inch. So it's going to cut right the way through, and it's going to cut this part out, and it's going to leave me with a 6x6 square. The profiling tool, click to select, and this takes you to our tool database. So this is what it would look like if you hadn't used it before. So if I go to inch tools, and then let's go to wood or plastic, and then I'll just use a 1/4 of an inch tool. Okay, click select, and that selected the tool for me. Okay, so I'm just going to use this at its most basic at the moment. So let's take a look at the Safe Z and the home. So if I click there, this gives me my Safe Z. So Safe Z is where the spindle or the tool retracts to before it rapids over to another area. So let's say that you had a part in the middle of this that was sticking up, but the tool needed to jump up and go to the other side of it. Then this would use the Safe Z to come up and then come across, and then it can plunge back down again. So if I were to set this up to say 1 inch, you also have a home X and a home Y. So what this does is when the job's finished, this is where it will go to. So if you wanted to maybe park this at the end of the machine, then you could change that to be, let's say 48 inches by 48 inches, and then put 1. So what this would do, it would go down the table by 4 foot in X and Y and come up 1 inch, and it would move it out the way for you. I'm not going to bother with that for this because I'm not actually machining anything. I'll just leave my Safe Z at 1 and my home Z at 1. So that's going to come back to the center. That's where my origin point is for this particular job. So I can enter a name if I want to. I don't have to do that. It will just create a toolpath that's called profile. So if I calculate that, it calculates a profile for me. Now this stays open just in case I want to modify anything that is in the settings. So if I want to tweak anything. If I did happen to close it, then all that I need to do is either right click on profile and select edit, or just double click on it and it will open it up. Right, so if I zoom in, you can see that what's happening is it's following the red on the outside is the actual tool path. So this is the path that the tool is going to take. And this is the center of the tool. Okay, so this is stepping out by 1/8 of an inch and machining it in order to give me the 6-inch squared piece that I want. Now, I'll just explain the profile again. So if I were to go inside and calculate it, then it steps inside by 1/8 of an inch. Okay, so this would give me a smaller piece. If I go along, then this will go along that particular vector. And I can't really see it very well because it's following it. Okay, this is quite useful if you were to do this using, say, a V-bit, and you just set the finish depth to be quite small, and this will create a chamfer around the edge for you. Right, so let's set it back to outside and calculate. Now, what I like to do is to do this within the 3D view. The reason being is because I like to see the depth that it's cutting to, and I can't do that within the 2D view. So if I switch to the 3D view, you can see that I've got my toolpath. It also shows you the rapid move. So in blue, I've got a rapid move. So it's telling me that it's going from the center, then going down to this bottom left-hand corner to start machining. So if I turn on the vectors, the reason being is that I've got this start point in green. Okay. Now, as I showed you in the node editing video, if I didn't want it to start there, what I can do is go into node editing. So let's go there. Whilst the toolpath is open, I can do that. It's absolutely fine. Let's say that I wanted it to start at this back edge here. Now the shortcut for this is P. So if I select P, it just inserts a node and creates a start point for me. You can also do it by inserting a node and then right clicking on it and changing that start node. But what I tend to do is just hover somewhere and select P on the keyboard. So that green node that I've got there is now the start point. So if I were to come out of node editing and calculate this again, you can see that it moves over to there, and that's where it starts now. Okay, so that's how you change the start point. Now, what I like to do is to actually see the depth that this is cutting. So if I middle mouse button and drag, I can rotate this around. And I can zoom in. Okay, so this makes a lot more sense to me because I'm not looking at it from a plan view. I can see the depth that this is cutting. I can see exactly where this toolpath is going. So I can see that it's coming from the center, it's rapiding over to this edge, then it's coming down, it's plunging down to a cut depth, and then it's going round, cutting it, and it's doing 3 passes. Now you may think it looks like it's doing 4 passes because there's 4 lines. This grey line that's at the top, this is just a 2D preview that's being shown. The reason being is because it's got this wireframe light bulb on here. So if I left click on that to turn it off, this is actually what's going to be cutting. So this is the 3D. So this is 3D visibility of the toolpaths. So I can turn that on or off like so. Just use the light bulb, it toggles it on or off. Now you can see if I zoom in that it's using 3 passes to machine this. Okay, now that is all denoted by the profiling tool. So if I were to open that up, you can see that I've got a step down of 0.1. So what's happening is the program's just dividing up this 1/4 of an inch by 0.1. And how many 0.1s can get into there? So you've got 0.1, 0.2, and then a 0.5. So it's just dividing it up into 3 equal cuts. So if I wanted to, let's say, do this as 2 cuts, let's do it at 1/8 of an inch and calculate. Okay, and it just does 2 cuts. Now what you have to do is turn off that light bulb again. So that grey one, just ignore it, don't worry about it. It's just the 2D view. If I do go back to the 2D view, you can see that it's not displayed. So you need to turn it on again then. Okay, so that's what the light bulbs do. So if we go back to the 3D view, you can see that I've got 2 cuts now. So I've got this 1/8 of an inch step down. If I wanted to do it in 1 cut, I could do a 1/4 of an inch finished depth and it would just go in 1 cut. Or I could just do it really large to make sure that it goes below that 1/4 of an inch. So if I were to select 1/2 an inch and calculate, turn off that grey preview, you can see that it's just doing this in 1 cut. So that's how you adjust your step down. Now, if you want to change the feed rate, plunge rate, or the spindle speed, then just enter it in here and then it will update for this toolpath. Now, notice how I said for this toolpath. Okay, so if you were doing this all of the time, then what I would suggest you do is go into the tool database and change the figures in there or enter your own figures. So there's a separate video for the tool database which shows you how to do that. So these changes only affect this one toolpath. So let's start taking a look at some of the options. So you've got allowance here. So if I go to the 2D view for this one, just so you can see this. So here you can see I've got my outside cut, and I'm going to take a look at allowance now. So allowance basically allows you to make an offset with this toolpath. So let's say this part was actually fitting into something and I wanted to make it just slightly smaller. Let's say by 10 thou. Okay. Now what you can do is you can add material or remove it. So if I go negative 10 thou and calculate, you can see that it brings the toolpath inwards. Okay, so this is making it smaller 10 thou per side. Okay, if I wanted to do it, let's say 5 thou per side, so it was 10 overall, it will bring it out. Okay, let's say that I wanted to do it, let's say 0.1 larger, it will move that toolpath out. So this saves you having to offset your original vectors. So there may be parts where you want to just make something a little bit smaller or a little bit larger. Okay. So let me set that back to 0 and calculate. You've also got sharp corners. So if I calculate this now, you can see that it creates these sharp corners. Now the reason for this is if you were creating, let's say, some sort of moulding that's got a mitre cut on there, let's say a picture frame for instance, and you were using a form tool. So let's say you were using some sort of OG tool with this quite intricate form on there. If you didn't have the sharp corners on there and you calculated it, the tool would go round here and it wouldn't create a perfect mitre. So it wouldn't have the line coming across here for the mitre and come to a sharp edge, because this would go round and the form would go round and follow it as well. So what you would do then is have sharp corners. So then the form comes up all the way to there and then comes across. Now, most of the time, personally, I don't use this because I don't normally do those type of jobs. But if ever you do have something like that, where you have a form tool and you need it to create this perfect edge, then you need to use sharp corners. Okay. So I'll calculate now. You also have a final pass thickness. And what does this do? Okay, so if I were to say have a final pass thickness of, let's say 10 thou and calculate. In the 2D view, I can't see that. Okay, we need to take a look in the 3D view for this. So I'll just turn off my 2D vector and take a look in the 3D view. Now what's happened here is it's came down in one pass at as far as it can go. So this can actually cut the whole part out. But I've told it that I want to actually do a final pass that's 10 thou thick. So I've left basically what you would call an onion skin on the bottom. Sometimes people do this maybe because they don't want to have the part move, and then the final cut only takes out a little amount of material, which obviously has less force on the tool, which means that it's less likely to move. So you can see just down at the bottom here that there are actually 2 passes. So if I were to turn that off and calculate again, you can see that I've just got the 1 pass. Turn it back on. I'll make it a bit larger so you can see it a bit better. So let's say 0.1 and calculate. So now I've got a 0.1 final pass. Okay, put that back to 10 thou and calculate. You can see that I've got a 10 thou final pass. Okay, so let's turn that off. Go back to the 2D view. Now you also have a final pass allowance. Okay. Now what this does, it does the edge rather than the depth. Okay. So here you can see that I've got my cut and it's coming straight to this edge. It's going to cut it out. It's going to be 6 inches squared. If I put a final pass allowance on there, and let's make this 10 fair as well, and then calculate, you can see I get 2 lines. So the outside line, what that's doing is it's machining it all out to the finished depth, and then it's going to jump in by 10 thou to finish it up, finish that edge up. So this is quite useful if you want to get a really nice finish on a particular edge. Okay, so you can rough it out and then come inside and maybe clean up that edge, and you got less force on the tool. So that's what final pass allowance does. So let me turn that off and calculate it again. Now you've also got a start depth, so most of the time this will be at 0, but maybe sometimes you want it to start lower than that. You don't want to machine a part that's already been machined. So you just enter your start depth there. Now, even though these are all coming down in Z and they're all negative, all of the figures that you type in here are positive. Okay, so the finished depth will actually be positive. I've seen a lot of people put negative figures in here, and they need to be positive for the finished depth. The tolerance basically affects how close the toolpath is to the finished piece. Now, most of the time, this is set quite low. Most of the time, I'll just normally set this to be maybe about a thou. Right, so I've explained the tool. You've also got cutting direction. So this is basically whether it cuts clockwise or anti-clockwise. So climb means that it's going in a clockwise direction, and conventional an anti-clockwise direction. So it's all dependent upon the finish that you want, the material that you're using. Some materials you would have to do climb, some materials conventional. The biggest tip that I can give you is, whenever I've been using this, is if you cut something out and the scrap piece looks better than the piece that you want, then switch these around. Okay, and that will affect the finish. So if you've got a scrap piece that looks really good and then the finished piece actually looks really bad, then switch the direction around and then you will get the opposite effect. So you get the finished piece would look really good, the scrap piece would look really bad. Okay. Now, leading, ramping, add bridges, I'm going to do those in a separate video. Okay. So this is basically how you use the profile toolpath. If I close that, then you got the profile toolpath here. If I click on this arrow, it tells me what tool I'm using. If I wanted to, I can right click on this and then I get some options like delete and rename. So if I rename that, and let's call it profile 1, for instance, just so I don't get mixed up. Another thing when creating toolpaths is that if you want to add any vectors to the toolpath once you've calculated it, you can do so. So let's say, for instance, I had a circle that was on the inside of this and I wanted to add it to this profile. Now what I can do is double click the profile, opens it up, it's automatically got the square that I cut out selected, and it knows that it's going on the outside of this. If I press Shift on the keyboard and select that circle that I've created there, this will automatically know, because this is on the inside, that I want to do an inside cut on this. Okay, so because I've selected the outside profile, it will automatically know that this needs to be an inside profile to give me the correct size. So if I calculate that, you can see it's added it to the toolpath. So that's how you can add vectors to a toolpath that's already been calculated.